Hello everyone. This is Shashank and welcome to Career Launcher. And today we are going to talk about CAT 2025 quantitative aptitude. And today we are going to start a new topic, and that is of geometry. So we are going to go step by step in geometry. We are going to learn the basic concepts of geometry, and we are going to solve few previous year questions and see what kind of approaches, what kind of shortcuts we can use to solve the questions. Let's start. In today's session, what we are going to talk about, we are going to talk about triangles. So let's start with triangles. So first of all, what is a triangle? By definition, we can say that triangle is a closed figure with three straight lines. Or you can say it's a polygon that has where number of sides equal to three. Anything is fine. So let's draw a triangle. So basically, this is a triangle. So triangle has three sides. So how many angles it is going to have? It is also going to have three angles. Let's say this is A, this is B, this is C, and let's say this is angle A, this is angle B, and this is angle B, and this is angle C. So that is the first thing that we know. Second thing is sum of internal angles of ABC is always going to be 180 degrees, irrespective of whichever angle can be anything, but sum will always be 180 degrees. Okay, so we also know that let's say talk about this. We also know that angle on a straight line is always 180 degrees. So basically, I can say that this is A, this is B, this angle is C. Okay, so I can say that this angle is, let's say this angle is theta. This angle is theta, right? So basically, I can also say that C plus theta is equal to 180 degrees, and A plus B plus C equal to 180 degrees. So from there, I can conclude that theta is equal to A plus B. So this is one of the things that we already know, that any external angle is equal to sum of two opposite internal angles in any possible triangles. So let me take an example. So for example, if this angle is 40, this angle is 60. So what is the value of this angle? This is definitely going to be 100 only, because that is equal to sum of two opposite angles. So this is angles in triangles. Now we are going to have three external angles in triangle. One is going to be this, second one is going to be this, third one is going to be this. And sum of external angles is always equal to 360 degrees. So sum of internal angles is given to us as 180. Sum of external angles is given to us sum of external angles will be equal to 360 degrees. And that's, I would say, that's not only true for triangle, that's true for any polygon. So it is true for quadrilaterals, it is true for pentagons, it is true for hexagons. So it is true, it is a general statement for all the possible polygons, and it is not dependent on number of sides. Okay, so when we are talking about triangle, so the most important part in a triangle is triangle inequality. And remember this is an extremely important concept. Now, what is triangle inequality? Triangle inequality, I would say, it's not a property of a triangle, it's a condition of a triangle. Now, what is the meaning of condition? That if triangle inequality is not true, there will not be any triangle itself. So that's why we call it, it's a condition of triangle. So to form a triangle, this must be true. So for example, let's talk about this triangle. And we have, let's say, this side is A, this side is B, this side is C. So it says that any side of a triangle should be greater than difference of other two sides. Should be greater than difference of other two sides, and as well as it should be smaller than sum of other two sides. So any side of a triangle should be greater than the difference and less than sum of other two sides. So this is a general statement. This is a condition for a triangle. If it is not true, there won't be any triangle. So for example, in a triangle, this side is 3, this side is 4. So what can you say about the third side? So generally people say it should be 5. Not necessarily. If it is 5, it will be right angle triangle. But the difference of 3 and 4 is 1. Sum of 3 and 4 is 7. So third side should be greater than 1, less than 7. Now, what is the important point over here? That third side cannot be even equal to 1. It should be greater than 1. It can be 1.1, it can be 1.8, but it can never be equal to 1. It can be 6.8, it can be 6.9, but it can never be equal to 7. So third side should be lying between 1 and 7. It can take any number. It can be 2, it can be 2, it can be 3, it can be 4, it can be 5, it can be any other number. But it will always be greater than 1, and it will always be smaller than 7. So this is the basic concept of triangle inequality for the formation of triangle. Okay. Now in triangle, there is another concept that we are going to call it as concept of area. So how do we calculate? So what I'm going to do, I'm going to write the general formula of area. So area of any triangle is given by, the formula of area is half into base into height. Okay, so how do we define what is base, what is height? Do we have actual definition of base and height? I think we don't. So this is like, I'll try to explain with different multiple figures. So if I'm drawing a perpendicular over here, so this side becomes base, this side becomes height. If I draw the perpendicular over here, so this is height and this becomes the base. If I'm talking about a right angle triangle, so in right angle triangle, people think that this is base and this is height. But if you draw the perpendicular on hypotenuse, so hypotenuse become base and this becomes height. So anything can be a base and a height. The side on which you draw the perpendicular, that becomes the base. So basically the underlying principle of base is you can draw perpendicular on any side and that side will become base. Now this is obtuse angle triangle. So let's talk about this. So this is your 90 degrees perpendicular. So this is going to be your height and this is going to be base. Remember, base is only going to till this point to this point, not till here, because this perpendicular is an external perpendicular. If you take this as height, this will become base. Okay. Now the second formula is half into AB sine theta. Half into AB sine theta. So basically, this is theta, this is A, this is B. So A and B are two adjacent sides and theta is angle between them. Remember this, theta is not a random angle, theta is an angle between them, and this is a generic formula for area of triangle. You can use it anywhere. Now third formula is R into S. Fourth formula is ABC upon 4R. And fifth formula, I think everyone knows, that is square root of S minus A, S minus B, S minus C. Now the problem is, this is a formula, Heron's formula, that I'm not sure when is the last time I have used this formula. And wherever we are writing S is actually semi-perimeter, that is A plus B plus C divided by 2. That is half of the perimeter. Okay, now what is R into S? Let's get into this. So R into S means basically if I'm going to make a triangle and there is a circle, that is an internal circle that touches all three sides, and there is an internal circle that touches all three sides. That circle is called as in circle, and small r is actually radius of that circle. So there R is equal to in radius. So whenever you see a question of triangle and question talks about in circle or in radius, always remember that you are going to use this formula somewhere. Okay. Now second one is ABC upon 4R. So basically this is a triangle and this is a circle. So basically external circle, the circle that touches the three vertices. So this is called as circumcircle, and capital R is actually the radius of that circumcircle. So it is called as circumradius. This is called as circumradius, and there are going to be three sides A, B, and C. So what is S over here? Semi-perimeter. What is S over here? Semi-perimeter. So wherever I'm going to write S, S generally denotes the semi-perimeter. But if in question it is written S, it can be anything. But the general thing about semi-perimeter is S only. Okay. So these are the 5 standard formula for triangles, and these are, I would say, generic formula. These formula are applicable for any type of triangle, and whenever and however you want to use it, you can use these formula in any question as you see fit. You don't have to worry about that it is applicable for this kind of triangle, it is applicable for that kind of triangle. No, it is a generic statement, and this you can use in any type of triangles. Now, there is one more concept that we are going to do. So, for example, if I'm going to talk about this, and let's say this from vertex, I am joining this, and this point, let's say this is A, this is B, this is C, and let's call it D. And BD is to CD is in the ratio of 1 is to 3. Now, question is, what is the ratio of area of ABD and ADC? Okay, so I need to figure that out. So if this is ratio is 1 is to 3, so this is x, this is 3x. So if I draw the perpendicular, so area of triangle ABD is going to be half into x into h, that is height. Area of triangle ADC is going to be half into 3x into h. So basically, if you are drawing a line from vertex to base, and if base is being divided in the ratio of A's to B, the ratio of area will also be A's to B only, because if you say half cancels out, x cancels out, h cancels out, so ratio of area is also 1 is to 3. So from vertex to base, if there is a line that divides base in the ratio of A's to B, the ratio of area will also be equal to A's to B. This is a generic statement. Now, second thing about triangle, for example, if I am going to talk about this, let's say this is A, this is B, this is C, and there is a line that divides AB, the point D divides AB, point E divides AC, and this ratio is, let's say, A is to B, and this ratio is, let's say, M is to N. So ratio of triangle of area of triangle ADE to area of triangle ABC, that will be equal to A into M, means this multiplied by this upon A plus B, that is equal to AB, into A plus AC, that is equal to M into N. So again, this is a general thing. You can, if you want, you can prove it by using this formula. That's fine. You are eventually going to get the same result. So let me take an example for this. So let's talk about this. For example, if I'm going to talk about, let's say this is going to divide in the ratio 1 is to 2, and this divides in the ratio of 1 is to 3. What is the ratio of area of this triangle? Is to total triangle. So simply the ratio of triangle 1 upon total triangle, that is going to be 1 into 3. This is this multiplied by this. So that is going to be 1 into 3. Divide by 1 plus 2 upon 3 plus 1. So that is going to be 3 into 4. So ratio of areas comes out to be 1 is to 4, and that's it. That's the total concept of this. Now the next thing, we are going to talk about types of triangles. Now, what are types of triangles? So generally triangles are divided on the two bases. One is on the basis of sides, second is on the basis of angles. But we are not going to get into too much detailing, because I think that's not needed from exam's point of view. So I'm going to take certain type of triangles, for example, equilateral triangle, and what are the properties of equilateral triangle. So I'm going to cover mainly 3 triangles: equilateral, isosceles, and right angle triangle. So what is equilateral triangle? So equilateral triangle says, uh, let me draw equilateral triangle. So this is equilateral triangle, and equilateral triangle, as name suggests, all 3 sides are equal, all 3 angles are equal. So this is A, this is A, this is also A. Now, if you draw the perpendicular, so if you draw the perpendicular, let's say this is h. So h is equal to root 3 by 2 times a. Okay. So basically this angle is 60. This is also going to be 60. Now, when you draw the perpendicular, it bisects the base as well as bisects the angle. So this is going to be a by 2, a by 2. This is going to be 30, 30. So whenever on whichever side you draw the perpendicular, it always bisect the base and bisect the angle. That is the property of equilateral triangle. So height is given as root 3 by 2 times a. Area of equilateral triangle is given by root 3 by 4 times a square. Now, this is not a generic formula. This is a specific formula that can be used only for equilateral triangle. It can never be used otherwise. Apart from equilateral triangle, you can never use this formula. So remember this. Okay. Now the second type of triangle is isosceles triangle. Now what is isosceles triangle? Isosceles triangle, as name suggests, that there are two sides that are equal. So if there are two sides that are equal, then there are two angles that are equal. Okay. So let's say this side is A, this side is A. Now, when you draw the perpendicular, it bisects the base. So let's say this is B by 2, B by 2. If this angle is X, this angle is X. Because two sides are equal, then two angles will be equal. Or we can say vice versa. If two angles are equal, two or sides are equal. Now, when you draw the perpendicular, it bisects the base. So this bisects the base as well as bisects the angle. So this is going to be y by 2, y by 2. Now, you might think then if this property is same, then what is the difference between equilateral triangle and isosceles triangle? The difference is in equilateral triangle, on whichever side you draw the perpendicular, it bisects the base. But in isosceles triangle, when you draw the perpendicular on the unequal side, it bisects the base. But if you draw the perpendicular from here, it won't bisect the base as well as it won't bisect the angle. So remember this, there is a difference. That in isosceles triangle, it bisects the base and bisects the angle only if you draw the perpendicular on the unequal side. But if you draw the perpendicular on one of the equal sides, the neither the angle will be divided, bisected, nor the base will be bisected. Okay. The third one is right angle triangle. So what is a right angle triangle? So right angle triangle says that there is exactly one angle that should be equal to 90 degrees. So this angle is 90, and let's say this angle is theta, then this angle should be 90 minus theta, because sum of internal angles should be 180 degrees. Okay. Now let's say this side is A, this side is B, this side is C. So I can say that C square is equal to A square plus B square. Now this is the only property of right angle triangle. I can say it is Pythagoras theorem. Now, there is one more important point, that whenever, if you know trigonometry, it's fine. If you don't know trigonometry, then do one thing. I am telling you fixed ratios. Remember these ratios. You will never need to worry about the trigonometry of sine cos 10 or those kind of things. Okay. So if in right angle triangle, the angles are 45, 45 and 90. So opposite to 45 degrees side is x, opposite to 45 degrees side is x, opposite to 90 side is root 2x. So ratio of sides become 1:1:root 2, and it is always true. Remember this, this is a standard ratio. It's not something that is very specific. This is not specific, this is a standard. Now, if in a right angle triangle, angles are 30, 60, 90. Angles are 30, 60, 90. Then ratio of sides is 1√3 and 2. That's it. So if you can remember all these things, you don't have to worry about sine cos 10. You can definitely get the values from here itself every time. Now let's move on to the questions and let's see what kind of questions we are going to get. Okay, let ABC a right angle triangle and BC as a hypotenuse. Okay, okay, so I am going to draw right angle triangle ABC. So this is A, this is sorry, BC is hypotenuse. So this is A, this is B, this is C, and the length of AB is 15. AC is 20. So basically, we all of us know that if I'm talking about right angle triangle, then the Pythagorean triplet should be applicable. So standard Pythagorean triplet is 3, 4, 5, right? Then we have 5, 12, 13. So these kind of Pythagorean triplets, I think everyone remembers. But if you see, it is 15, it is 20. How we are going to use Pythagoras theorem? Either you use Pythagoras theorem and get the side, or alternate approaches. I can say this is 5 into 3. This is 5 into 4. So one side is 3, second side is 4. So third side should be 5. So it means third side should be 5 into 5, or I would say 25. I don't need to use Pythagoras theorem and calculate the values. I can directly get the answer from here. Okay. Now, uh, the minimum possible time required to reach hypotenuse from A. Okay. So A is this point, and from this point, I need to reach at this point, and I need to take minimum time. So if I need to make minimum time, it means I need to take the shortest distance. And what is the shortest distance? Shortest distance is always perpendicular distance from one point to another point. Okay. So I need to find out the length of perpendicular. How can I do that? Okay. So first of all, let's call this length as h. What is the area of triangle? That is half into 15 into 20, right? Okay. Now, what is the perpendicular? What is the area of the triangle? That is going to be half into base. Base is 25. Height is h. We have seen that in multiple ways we can calculate the area of a triangle. If I take this as perpendicular, my hypotenuse becomes base. So half half cancels out. 5 is 3. This is 4. So h comes out to be how much? 12 kilometers. Okay, so how much time we are talking about? So our total time is going to be, so distance is 12, speed is 30. So how much time we are going to talk about? 12 upon 30 hours. If I multiply it by 60, what I'm going to get? That is going to be 24 minutes. And my answer of this question is going to be 24. Okay. And remember this thing, that when we are talking about a question that is theta, in theta, your answers can never be decimal. So if you are getting your answer in decimal, then kindly reread the question, because what is a generic mistake that people might make in this question? That if they are getting the answer as 12 by 30, so they can write the answer as 0.4. But if answer is 0.4, it's in hours. Answer is not wrong. But in theta, the question is talking about the answer in minutes. So that's why 0.4 hours will be considered as a wrong answer instead of 24. Okay. So remember this. Whenever you are solving a question that is theta, your answer can never be decimal. It can never be negative. Now let's move on to the next one. What does it say? Let triangle ABC be right angle triangle, okay, with hypotenuse BC of length 20. Okay, okay. So basically we have hypotenuse BC. So this is A, this is B, this is C, and this is right angle triangle, and this is BC is 20. AP is perpendicular to this. Okay, so AP is perpendicular to this, then maximum possible length of AP. So remember this, if hypotenuse is, let's say H, the maximum possible distance of the perpendicular can never be greater than H by 2. So the length of AP can never be greater than 10, and that's the answer. And if you are little comfortable with the circle, then this can be proven by circle, that this is, let's draw this as BC. This is your right angle triangle, and it is going to be diameter, because diameter always subtends an angle of 90 degrees. This is point A, and so what is the highest possible length of this and this? The length of perpendicular, that can never be greater than the radius, or that can never be greater than this, the half of hypotenuse. So anyhow, we are going to cover this concept in the session of geometry, in the session of circle. But for now, you can remember that the length of perpendicular on hypotenuse can never be greater than half of hypotenuse. So if this length is 20, the length of perpendicular can never be greater than 10. So answer of this question is going to be option D, that is 10. Now let's move on to the next one. What does it say? From an interior point of equilateral triangle, perpendiculars are drawn on all three sides. The sum of the lengths of three perpendiculars is S. The area of triangle is what? Okay. Okay. So sum of perpendiculars is S, that is given to us, and in equilateral triangle. Okay, so let's talk about equilateral triangle. We have already seen the properties of equilateral triangle. So let's, this side is A, this side is A, this side is A, that is perpendicular. Okay, so what is the area of this? That is going to be root 3 by 4 times A square. We know the area and where A is the side. Okay, and what is H? H is given to us as a root 3 by 2 times A. That we also know. Okay. Now, from a point, sum of perpendiculars is equal to S. So I am assuming this is the point itself. So from this point on this side, what is the length of perpendicular? That's 0. From this point to this line, what is the length of perpendicular? That is 0. From this point to this line, what is the length of perpendicular? That is root 3 by 2 times A. So sum of perpendiculars becomes 0 plus 0 plus root 3 by 2 times A, and that is equal to S. So I can say that A is equal to 2S upon root 3. Now what I'm going to do, I'm going to plug in this value over here. So area comes out to be root 3 by 4 times A square. And what is A square? That is 4S square upon root 3 square is 3. So 4 cancels out. So this comes out to be S square upon root 3, and that is going to be option D. So again, if you are not very convinced with this, what you can do, you can assume that that point is this, what median point, and then calculate the sum of the perpendiculars. Eventually, your answer is going to be same. So you don't worry much about it. Okay. Now the next one, let D E be points on the sides of A and B. Okay. Okay. So D and E. Okay, so on A, B, and C. Okay, so let me draw a triangle. This is A, this is B, this is C. D is on AB, and AD is to BD is 2 is to 1. Okay, so this is going to look like 2 is to 1. Okay, AE is to CE is 2 is to 3. So this is point D, this is point E, and this is 2 is to 3. Now area of triangle ADE is 8 square centimeter, and question is talking about. So we have already seen the concept, that is area of triangle ADE upon area of triangle ABC, and that is equal to what? That is equal to this multiplied by this, that is 2 into 2, divide by this total length is 3 into this total length is 5. Okay, and it is given to us that area of triangle ADE is 8. So what is the area of triangle ABC? Let's say the area is A. Okay, so I need to find out the value of A. So this is equal to 2. So from here I can say A is equal to 2 into 3 into 5, and that's equal to 30. So what is the area of triangle ABC? That's going to be 30, and that's the approach to calculate these kind of questions. Now, let's move on to the next one. In a triangle ABC, angle BCA is 50. Okay, okay. And D and E are points on AB and AC. Okay, so what I'm going to do, I am going to draw the triangle. So whenever you have a question on geometry, so the first thing you are supposed to do is to draw. If you're not drawing, you can't imagine everything, and it is going to put a lot of pressure on your brain, because to remember so many things at the same time becomes a little difficult. So what you should do, you should just draw everything, whatever question is talking about, just draw it. So this angle is given to us as 50. Okay, so from here I can say angle A plus angle B plus angle C should be 180 degrees. So from here, the first thing I can conclude that angle A plus angle B should be equal to 130 degrees. Okay. Um, it is D and E are the points on AB and AC. Uh, D is on AB and E is on AC. And question says that AD is equal to AE. Okay. Okay. So this is D, this is E. Okay. F is a point on BC. Okay. So F is a point on BC such that BD is equal to DF. BD is equal to DF. Okay. So basically BD is equal to DF. So that is what that is given to us. Fair enough. Now question is talking about what is the value of this. Let's call it theta. Okay. This angle is A. Okay. This angle is B. Okay. So if this angle is B, what is going to be this angle? This angle is also going to be B. Okay. This angle is also going to be B. Okay. Now what is going to be this angle? This angle is going to be 180 minus 2B. Okay. This angle is A. Sorry, this angle is A. Okay. So what is going to be this angle? This is theta. Sorry, I think I made a mistake over here. So basically, this angle is okay. So this angle must be equal to this angle. AD is equal to DE. Okay, and BD is equal to DF. Okay, and AD is equal to DE. Okay, so this is A, and then this is going to be what? This is B. BD is equal to DF. Okay. So BD is equal to DF. So this is B. This is also B. This is going to be 180 minus 2B. Okay. And this is okay. So I think this is going to be a little trickier. So what I'm going to do, I'm going to take an alternate approach. This is B. So this is going to be 180 minus B. Okay. Now this angle is A. Just let me, I think I am making a mistake somewhere. Just let me replot the graph. Okay, draw again. So this angle is A, this angle is B, this angle is C, angle C is BCA, that is 50 degrees. So from here I can say that angle A plus angle B is equal to 130 degrees. Now on AB there is a point D. Okay, so that is, this is a point D, and on E is okay. So I made a mistake. AD is equal to DE, not AD equal to AE. So that was the mistake point I got. So that's always good to redraw and resolve the question. Okay. So I know that AD means this is equal to this. Okay. So these two sides are equal. Okay. And these two sides are equal. Okay. So this angle is A, I know. So, and this side is equal. So this angle is also going to be A. Okay. This angle is B. And what is going to be this angle? This angle is also B, and this angle is theta. Okay. Now, what is this angle? This angle is going to be 180 minus 2B. Okay. What is this angle? Theta. Okay. What is the value of this angle? This angle is 180 minus 2A. Okay. And summation of all three angles must be equal to 180 degrees, because this is an angle on a straight line. So this is 180. So 180 cancels out. So I can say that theta minus 2 times A plus B. and that is equal to, sorry, 180 plus theta, and that is equal to 0. So 180 plus theta is equal to, I already know that a plus b is 130 degrees. So that comes out to be 260 degrees. So from here, I can say theta is equal to 80 degrees, and that's the answer directly. So I can directly calculate the value of FDE, and that is equal to 80 degrees. And this is the approach. So whenever you are stuck in a question, and I think when you make a mistake once, you tend to repeat the same mistake again if you are going to recheck your solution. So instead of that, just reread the question and draw everything. More likely you will get it right in the second time. And I'm sorry I made a mistake in reading. Okay, so if anyone has a doubt, you can ask me a question. You can drop a message on the comment box. And thank you.